Hi everyone and welcome to this tutorial session. In today's session, we want to solve this exponential equation. It's a math Olympiad question from China. Root 2 raised to the power root x minus root 2 raised to the power root y is equal to 60. Solve for the values of x and y. You are all advised to watch the solution from the beginning to the end because there will be a lot of explanation that will be given as we progress in our reasoning and building up of the solution. So without any further ado, let us start. Root 2 raised to the power root x minus root 2 raised to the power root y is equal to 60. Solve for x and y. Now the first thing, let us rewrite the equation knowing that square root means power half. All right, so root 2 is 2 to the power half. Now raised to the power root x. Root 2, 2 to the power half raised to the power root y is equal to 60. Power of power laws, we take the outer power multiplied by the inner power. This gives us 2 to the root x all over 2 minus 2 to the root y all over 2 is equal to 60. This is what we have. Now, it usually occupies much space when we write like this. And if we continue to work in this form, in this manner, we're going to be having too many writings, which can get things mixed up. So we want to simplify our work by bringing in two new variables. Now let's call them m and y. Let m be root x all over 2 and n. The two new variables are m and n, not m and y. And n equals root y all over 2. Now, when we make this substitution, our equation becomes 2 to the m minus 2 to the n is equal to 60. We see it is much it is a lot easier to work with simple expression like this than when we have too many things written up there. So we have to solve for m and n. But remember, the equation says solve for x and y. When we get the value of m and m, we will now come to this substitution that we made in order to solve for the x and y. Now, when we look at this, we have the following analysis to make. The first thing is that we have the difference of two index expressions that have the same base, 2 to the power m minus 2 to the power n, giving us a positive natural number. That can only happen when the powers are also natural numbers. So that's the first thing that we take note of. So we take note of 1, m and n must all be natural numbers. Okay, the second thing we take note, again, we are subtracting this index expression with the base 2 minus this index expression with the same base 2, giving us a positive natural number, means that this power, the m here, must be greater than the power n. If that is not true, then we cannot have a positive result. The power m here must be greater than the power n. So m must be greater than n, strictly greater than n. Now, if that is the case, then we can write m in terms of n as m is equal to n plus some natural number k. Okay, plus some natural number k. K must be a natural number. Since m is strictly greater than n, m should be that n plus some other whole number. That is very, very clear. So now let's rewrite this our equation now using this new relation between m and n. So we're going to have 2 in the place of m, we're going to have n plus k minus 2 to the n, giving us 60. This means 2 to the k into 2 to the n minus 2 to the n is 60. So we see 2 to the n is common, so we'll factorize out 2 to the n. So 2 to the n, we'll bring it out. We'll have 2 to the k minus 1 is 60. So this is what we get. So we end up with two index expressions multiplied together to give us 60. So we'll need to find the values of n and k. Now, what is the reasoning here? The only way forward is for us to decompose the number 60 so that we'll be able to form two equations from which we'll be able to get the values of n and k. Pay attention because a lot of reasoning will follow after the decomposition. Now let's see the possible decompositions of the number 60. The number 60 can either be decomposed as 1 times 60. It can also be decomposed as 2 times 30. It can also be decomposed as 3 times 20. 3 times 20. It can also be decomposed as 4 times 15. Alright, and can also be decomposed as 5 times 12. So these are the possible decomposition of the number 60. Now, which of these decomposition will help us solve for the value of n and k? So we're going to be making this analysis based on what we have here. So from there, you're going to see we're going to eliminate the decomposition that will not help us and only end up with that single decomposition that will enable us find the value of n and that of k. Now, let's start with the first one. 1 multiplied to 60. So we are seeing 2 to the n into 2 to the power k minus 1 is 1 times 60. Let us take the first one. Now look at it carefully. 2 to the n must always be an even number. 2 raised to any power will always be even. And then 2 to the k minus 1 will always be an odd number. Okay? For example, 2 to the 3 is 8. It's an even number. 2 raised to any power will be an even number. But when we come and we subtract 1, 8 minus 1 is 7. 7 is an odd number. So any power of 2 minus 1 will always give us an odd number. So with that at the back of our mind, let's look at our factors that we have here. 1 is an odd number and 60 is an even number. So it therefore means if we match things up, 2 to the n will go for 60 and 2 to the k minus 1 will go for 1. Alright, so we're saying 2 to the n is 60. Now looking at this, it means there is going to be a certain natural number so that when we raise 2 to that power, it will give us 60. But we know that there is no power of 2 that gives us the result 60. Consequently, the choice 1 times 60 is not a good choice. And so that is cancelled. Now, what about the next choice? 2 times 30. What about the next choice? 2 times 30. 2 times 30. Now, look at it. We said this number must be an even number. All right. And that this one must be an odd number. But when we look here, 2 is even, 30 is even. So automatically, this choice will not work. one of the factors must be even, the other one must be odd. So this one will not work. So we just take it off. So this one is cancelled. Let's take the other one. 3 times 20. We have 3 times 20. Again, one of the factors here must be even and the other one must be odd. So this even will go with this even. Again, 2 to the power n 20. There is no power of 2 that will give us the result 20. All right, there's no number to which one we raise 2 will get 20. So that choice is cancelled. All right, so this one is cancelled. Now let's take this last one. Let's first of all take this one. All right, 5 times 12. We have 5 times 12. Again, even will go with even and odd will go with odd. Is there any power of 2 that will give us 12? No. There's no power of 2 that when we evaluate will get 12. Therefore, this choice is also cancelled. Finally, we are left with the remaining choice, which is 4 times 15. Let's take this one. 4 times 15. 4 times 15. Even will go with even, odd should go with odd. So we're having 2 to the n is equal to 4. 4 is the same as 2 squared. So 2 to the n is equal to 2 squared. This simply means that n must be 2. Okay? And then, of course, 2 to the k minus 1 is 15. Take the minus 1 from the left to the right. We have 2 to the k is equal to 15 plus 1. So we have 2 to the k is 16. But 16 is the same as 2 to the power 4. So we have 2 to the k. So we end up having we end up having we end up having 2 to the k is equal to 2 to the k is equal to 2 to the 4. Now, since the bases are equal, we can just equate the powers. So the value of k is 4. The value of k is 4. Now we know the value of n and we know the value of k. Remember, we're not asked to solve for n and k. We're asked to solve for x and y. Okay? But we know that m is n plus k. So our n is 2, our k is 4. So m is 6. Now that m is 6, again, we're not asked to solve for m. We're asked to solve for x and y. We know that m is root x all over 2. So we'll put 6 for m. 6 is equal to root x all over 2. When we cross multiply, we'll have 12 is equal to root x. To remove the square root, we square. Opposite of square root is square. So finally, we'll have x is 144. 12 square is 144. So we found the value of x as 144. What about the value of y? All right. Also, we know that y is root y all over 2 is n. So root y all over 2, we found n to be 2. When we cross multiply, we'll have root y is equal to 2 multiplied to 2 is 4. Now when we square both sides, When we square both sides, we're going to have y is equal to 4 squared, which is 16. So finally, we have solved for x and y. X is 144 and y is 16. Let us check. Let us do the checking to be sure of our result. Now, checking. We're going to put x to be 144 and we're going to put y to be 16 in our original equation to see if the left hand side agrees with the right hand side. So we have root 2 to the root x. We simplified everything to 2 to the root x all over 2. Now this gives us 2 to the root 144 all over 2, which is going to give us 2 to the 12 all over 2, which is 2 to the 6. That gives us 64. Now, this other one is 2 to the root y all over 2. 2 to the root y all over 2 is going to give us 2 to the y is 16, root 16 all over 2. It's going to give us 2 to the root 16 is 4. 4 all over 2. It's going to give us 2 to the 2, which is 4. It's going to give us 2 to the 2, 2 to the power 2, which is 4. Okay? Now, let's put everything now in our equation up there to see if the left hand side agrees with the right hand side. So putting it up there, are we going to have this one? It gave us 64. 64 minus this one gave us 4. What do we get? We have 60. So we'll now see that the left hand side gives us the right hand side. Therefore, conclusion, x is 144, y is 16.